On section 7-2, we are dealing with similar polygons, and on the first two, we're basically just trying to prove that either yes, they are similar or no, they're not. And what information is given to us here is that we have congruent angles here, and then based on the third angle theorem, we know that because these two angles are congruent to these two angles, then that last and final angle must also be congruent. So we write a similarity statement by writing triangle ABC is similar to triangle DEF because angle A is congruent to angle D, angle C is congruent to angle F, and angle B is congruent to angle E based on that third angle theorem. And then we can also determine it by the sides here. If we have the same scale factor on each one of these sides as compared to these sides, then we also know that they are similar. So we compare the 6 to the 4 and we get a scale factor of 3 over 2. And then compare the 9 to the 6, we get a scale factor of 3 over 2. And then again the 10.5 over the 7, and that also gives us a scale factor of 3 over 2. We do the same thing on number 2. It gives us that these two angles are congruent to these two angles, and these two angles are congruent to these two angles. So we write our similarity statement by stating that rhombus PQRS is similar to rhombus WXYZ based on the facts that all of these angles are congruent. And then we can determine the scale factor based on these sides. They're all the same, so we only have to do it once, and our scale factor is 2/5 after it's been reduced. On the next 4, we basically are just going to use our proportions to figure out what x is. We need to make sure that we're using the same sides from one polygon to the other. So as an example, we look at the congruent angles here and here, and then the congruent angles here and here. So we know that segment AD should be similar to EH. So we take X from HG and then we put it over the 13, which is the side that should be similar on this polygon here. And then we take another side that we know. In this case I took FG, which is that 13, and then I set it over the similar side, which is the 26. Then I cross multiplied to get the 26x equals 169, and that gives me my x equals 6.5. Number 4 is the same way. Again, we have to make sure we're using the sides that are similar to each other. So if I actually turn this triangle and face it up so it faces the same way as this triangle here, I know that side ST is similar to side WX. So I take x over 5 and set it over 4, and then I take the other one here, my 9, and set it over the 3 because it's similar to this side. And then I do my cross multiplication there. Make sure to distribute here. 3x times 3 times 5 gives us 15, and then 9 times 4 equals 36. Then I solve for x, where we get x is equal to 7. Number 5. Again, we need to make sure that we turn our polygons to where we have the similar sides on the same sides, and we're comparing the same sides when we're doing our proportions here. I took and TW is similar to side SR, so x plus 1 over 9, and then I'm going to cross multiply it by 10/3, which is side UV, and I compared it to side PQ here. When I cross multiply it again, don't forget to distribute there. 5x plus 5 is equal to, when you multiply 9 times 10/3, you get 30 here, and then you solve for x, so that gives us x is equal to 5. And then lastly, number 6, again, angle S is similar to angle M, and then I have angle P is similar to angle L, and then angle T is similar to angle N. So therefore I'm going to compare side TS, x minus 1, to my 8. And then I'm going to compare my side PS, x plus 2, to MN, which is 10. Then I'm going to cross multiply. Again, don't forget to distribute. 8x plus 16 is what I got here, and then 10x minus 10, and then you solve for x, and that's how you get x is equal to 13.